Hello and welcome back to Survey of Biology, and today we're going to start the second section of Unit 8 on population growth and dynamics. And what we're going to look at today is mathematical models of population growth. So if you remember the last section, we talked about things like exponential growth and how they're represented by a J curve. We talked about logistic growth, where populations will have a carrying capacity that they level off at, and the S curve. And what we're going to look at today is two mathematical models that allow us to kind of quantify, put some numbers to how fast a population grows or how big a population might get after 10, 20, 100 years. And so the two that we're going to look at, one is doubling time. And for that one's relatively straightforward. It's called the rule of 70. And then the second one we're going to look at is exponential increase. So when we talk about a J curve, we're going to use the population down, or the equation down at the bottom that allows us to calculate what the new population will be. So the first one we're going to look at is doubling time. And for doubling time, what we have to remember is something called the rule of 70. And what that is the number of years to double, the number of years for a population to double in size is going to be equal to 70 divided by the annual percentage growth rate. So if a population is growing at 25% per year, the annual percent growth rate would be 25. If it was going at 10%, it would be 10. So if a population was growing at 10% per year, how many years would it take to double? Well, 70 divided by 10 gives you 7. There's your doubling time. And that's a pretty quick rate of increase. Most populations aren't going to double in 7 years, but that's how we use the rule of 70. We just take the percent increase, divide it into 70, and that gives us our doubling time. So here we go. Here's an example here where dt is the doubling time. And down at the bottom, if there's a growth rate of 5% per year, what is the doubling time? Well, dt equals 70 divided by 5, and that comes out to be 14 years. So you just plug in the percent increase, divide it into 70, and that gives you your doubling time. Now, the exponential equation is a little bit more tricky, and you better have a calculator ready when you try to do this. So what the exponential growth is this happens when a population increases by a fixed amount or percentage each year as it goes through. And what it's equal to the new amount, which they call A. I actually like to call it N for the new population, but it's equal to the principal amount if you're talking about money, but this would be the original population times 1 plus the rate of increase as a decimal, and this is important, raised to the power of how many years, the time that it's going to be increasing. And here's where it's going to be very important that you have a calculator, and most of your calculators will have an X to the Y button. That's the button that you're going to want to use when we raise something to a power here. So as an example, if we have a population of, let's say, turtles, and we have 100 turtles, and we want to know how many turtles will there be in 20 years if they're increasing 10% per year. Well, let's plug things in. Our original population, P, is going to be 100. We're going to multiply that by 1 plus the decimal is 0.1 raised to the power, which will be 20 years. And so now we take our calculator, so this is going to be 100, 1.10 raised to the 20th, and 1.10 raised to the 20th comes out to be 6.73. We multiply that by 100, and our population of turtles after 20 years will be 673. So it's a little bit trickier. We need to do a little bit of math, but if you just follow the equation, plug in the variables that they give you, you should be all set. So let's try one more right now as we walk through. So here's an example of what it might look like. So if a population of 50 chipmunks increases by 15% each year for 10 years, how many will there be after 10 years? Well, let's set up the equation. So the equation is N, our new population, is equal to the population 1 plus the percent raised to T. So N is going to equal 50, that's our original population, times 1 plus, now what's the decimal equivalent of 15%? 0.15 raised to the 10th power. So this becomes 50 times 1 point, let me go back on that for a second. There we go. 1.15 raised to the 10th power, which is going to be 50 times 4.05. This is the step right here where you'll need to use your calculator. So here's where you'll use that X to the Y button. And if we multiply that through, we get a population of 202 chipmunks. It actually comes out to be 202.28, but we'll round to the closest whole number, and this becomes our new population of chipmunks afterwards. So we'll need a little practice with this, but with a little practice you'll get very good at it, and you'll be able to solve these type of problems in no times. So again, thanks for your time.